Okay. So this is a glimpse of the machine, which is in the second floor in this picture. So I'm a bit panicked right now because I don't see the green box in my screen. I was still sharing. Can I just double check with people that you can see my screen? Sorry about this. Can anyone just have a thumb up? Again, just confirm that you actually can see my screen. Good, sweet. Sorry about that. Like usually Zoom has a green box, and I don't see a green box right now, so I'm not sure what's going on. Okay, as long as you guys can confirm, thank you. So this machine is I'm on the bottom level here, beneath on behind one of the window. This is the data. This is the rack in the second floor in this tinderbox. We have doors, which is what we call hot IO, that enclose the heat. Otherwise, it's going to heat up the entire data center. This is one of the generation of CPU we use. We also have some latest CPUs, Intel Sapphire Rapids, excuse me, which they use water cooling. Well, this one uses water cooling as well, but the latest water cooling cools the power supply and everything in the node, so there's no need to use hot IO. Um, so you see the setup for different nodes as well. This is a rack. I just want to point out the one thing is this light blue or cyan color. This is a fiber, provides the internal inter network connecting, which is called InfiniBand. This is not Ethernet. This is interconnection between different nodes. So make sure that different nodes they have a very high speed high speed network. So they go through the roof into each nodes. Okay. Gadi artwork. This is the artwork you see in front of the aisle. Um, Gadi is the original Ngunnawal language here in Canberra, meaning to search for. This was Gadi, the supercomputer was commissioned in late 2019. We're actually getting close to the end of its life cycle now. We are planning at this point buy a new machine, but that does not mean Gadi will be phased out. We'll still function Gadi for um, to serve like at this point it's nothing certain now, but likely we'll keep using Gadi as it's still a um, um, will maintain the machine. So interface to Gadi, this be a network thing here. What this diagram tells you is how the network is configured for Gadi and how you can access Gadi. So on this black box is SSH, secure shell, which means at your laptop at home, you can just remotely connect to the machine through SSH. SSH, if you have used Linux or Mac, they are by default. I do believe in the latest Windows, SSH is also a default protocol as well, which means if you open up the terminal, you can SSH to the machine with the host name. So the network is through OARNET. OARNET is a network dedicated for Australian universities. So, through this network, you can connect pretty much all over the world. Because of the machine, because of the machine's vendors requirements, there are few countries that you can't, if you are residing, well, if you are in those few countries, you won't be able to connect to the machine. But I guess you'll have a bigger trouble to worry about if you are in those few countries rather than connecting to Gadi. Um, so NCI Neuron Cloud, also it's the cloud service we provide. They connect through Gadi through OARNET as well. Here we have this icon here, ARE, Australian Research Environment. This is a platform or web browser based platform that provides easy access to Gadi, particularly for people using R Studio or Jupyter notebooks. You just go to your web browser and go to the domain. I believe it's are.org.au. And then you can do Jupyter, then you can submit Jupyter Lab session, Jupyter Notebook sessions, and at the back end, it's running the Jupyter Notebook on the Gadi hardware. If we have time, we can go through a bit more about this. Um, but holistically, this is the connection network, how you can connect to Gadi. I'll pause here for a couple of seconds and have a read through the Q&As. Uh, so I'm gonna read out the questions so other people can benefit as well. Um, so anonymous attendee, I want to ask if my group only has 2 TB in the Scratch directory and I need to run a high fidelity simulation which will produce more than 2 TB. What can I do? Quick question is you need to ask for a bit of extra. We'll get to that later in the storage part. So Scratch default is 1 TB. I think you got 2 TB. It's probably you negotiated with the team already. If you need more than that, you need to again negotiate. Well, send your request and give reasons why you need to more than 2 TB. Um, okay. You probably know this. You're probably doing this already, but sorry if I step on your toes. Um, maybe you have considered, different compression algorithms that compress the data down to much smaller size. Just yeah, just saying. Um, and I apologize if you have done this. I'm pretty sure you probably been doing this already. So from Brody, so we can connect to Gadi overseas. Yes, as long as you have internet, you'll connect to Gadi. Apart from in a few select countries. Um, One thing I should also mention is because similar as the vendor's requirement, if your research is nuclear physics, um, you need to be, well, nuclear physics research, as far as I checked last time, is you need a special commission to do to do nuclear research on this mission. Um, just for just in case anyone's having intended to do that research. Nothing we can't accommodate, but just talk to us individually, and we will go through some clauses with you. Okay, so here's a spec. So just like your home the computer, you have X number of computer nodes, and what's your speed, and whatnot. So I will not go through all details because they might not necessarily be interested to you. I just want to point out a few key messages here. We're fairly big sizes. And another unique thing is we're not just big, but we are also heterogeneous in a way that we have a CPU and GPU all together. It's actually quite special. As they are not to get like when they present to users, it's presented as one machine. even for CPUs, we have different generation of CPUs. From some old ones, Board Wheel Skylake, to not so old ones, Cascade Lake, and to latest ones, Sapphire Rapids. What does that mean to user, to you guys, is they have different speed, because well, some are old, some are new. They also come with different charging rate because when you run the job on Gadi, your job is charged with some charging rate. So Cascade Lake is if you run your Cascade Lake for 1 hour, we charge you 2 service units, which is not the case when you run Skylake and Board Wheel because the older generation, um, they are slightly cheaper in terms of this charging rate. So if your workload does not require, the fastest and latest CPU, and you're happy to wait a bit longer, well, even the different CPU does not matter that much because your code is maybe memory bound. Um, you can consider using those slightly older CPUs by specifying different queue types, which we'll talk about later. With this, you get charged less. B, those two queues are usually slightly more empty than the normal queue, which is Cascade Lake, or normal SR, which is Sapphire Rapid nodes, which means you don't have to wait. Your job will not wait in the queue for a long time. So that's one message out of this slide. And the B is for about GPUs. We similarly like the CPUs, we have various three types of GPUs you can use at this point in the machine. The main power horse here is the V100 GPUs. We have 640 nodes, 640 cards in 160 nodes. Very recently, we have also installed 120 H200 GPUs. They are fairly recent GPUs in 30 nodes. And we have two A100 nodes, um, um, which we acquired as sort of experiments a couple of years ago. So in terms of the GPU generations, H200 is later than A100. A100 is later than V100 or newer. Uh, Maybe a few quick messages. Scratch storage is with very high I/O speed, 400 gigabytes per second. They are part of Gadi. So when I talk about storage, it's separated from Gadi, which will, again, I will delay this discussion later, is we have two storage server, one's Scratch, one's GData. There are two separate storage server. Scratch is part of Gadi, and because it's part of Gadi, it actually has faster I/O speed as well. They are given to user by default. So um, 200 gigabits InfiniBand HDR network. To put it into a perspective, for example, ANU right now, I'm where I'm standing. The university network, the link is 10 gigabits per, and whereas this internal network in Gadi is 20 times than that. That means when you run the job on multiple nodes, the data transfer between different nodes can be very, very fast. Lastly, maybe for some of you who may care about is the operating system is Rocky. I think we're running on Rocky 8. We're about to upgrade to Rocky 10. I think we'll skip Rocky 9, as I'm aware of last time. When we debuted, we were 24th as fast in the world. Of course, over the years, our rank dropped, but also we've added a new compute node as well. So um, overall, this is a machine in high demand. If you go to the website, there's articles from one academic published probably a month ago. Then the article was about research supercomputer these days is in high demand because, again, like what I mentioned in the beginning, its landscape has changed. It's no longer 5 years ago. This is a super niche, super like specialized tool, only for like very well trained, very uh, um, well trained and specialized areas. More and more people start realizing the power and the benefits of using large scale computation. So the demand has rise significantly over the last 5 years since I joined. However, well, because we are a research supercomputer, we're not AWS, we're not, um, Elon Musk's Grok or whatever. We rely on the government fundings. And when government give us funding to build a better machine only for researchers, the government listen to the researchers say, you guys benefited from this machine? Is this actually critical to the nation's research? Because without the good feedback from our researchers, we will not get that public funding to underpins our the maintenance of the machine. Putting to some perspective about the work related to maintain the machine. I used to do some during COVID time. I used to be in the front reception desk. What the job I did every day was some hard disks of the storage server, because we have so many of them. The maintenance goes every day. There are a few of them just got wear out because once you got 100 200,000 of hard disks, they hit that failure ratio, and every day you guarantee have a few busted ones. And every day like I have to put them to to delivery and get the new ones back. So that is much maintenance required. Of course, not just me sending the things. The storage team, they actually do the storage maintenance. But that put into perspective is, this machine it's not like your laptop or desktop. You turn down and surely it will run for the next 3 years. No, like actively requires manpower to man the machine. So that's a bit background, well, spec about the machine. For users to use this machine, um, this diagram is probably one of the most important one in the slides. I will slowly go through this one. This one gives you a holistic overview about the machine. So you have the mental image in your mind, then you can navigate once you log in. Because once you log in, you got a shell. If you're not familiar with shell, you don't really know where to go, right? This is the roadmap. This slides is the roadmap gives to you that you can let me print this here. Zoom in this one. This is the roadmap slides that you can guide you through your operation on Gadi. So once um, so if you walk into the data center, this map is basically how the data center lays out as well. On the left one side, half of the data center is the storage. You got your Scratch storage server. You got your GData storage server. MDS and OSSS there are some particular jargons how the storage is organized. In short, I mentioned about we probably have 100,000, 200,000 hard disks, but all the large number of hard disks, they are mounted as one mount point to users, to you guys, right? You don't go to the machine and go to hard disks number one, hard disk number two, and then store your data separately in different hard disks. No, what you see is a single mount point. You store the data for users, you store the data in a single mount point, but in the underlying and behind the scene, we have this last parallel file system that distributes your single file into multiple hard disks. That's um, with that you can achieve data integrity and resiliency, because if one hard disk dies, you can still do checksum and other techniques to recover the information on that disk on the disks. Actually, there are also for GData, I think that mirrored as well. We have another data center, Huxley, the building behind me. And they are persistent data. So GData here are the persistent data storage. Okay. Now, on the right-hand side of this picture is the compute nodes. It is in semi-sync data center, half the data center are the storage nodes server. Half of the data center is the compute node server. So we have 10 login nodes. Those are nodes when you go log SSH to Gadi. These are the nodes where you are landing. They have a connection to the network, to outside the internet. Same as the data mover nodes. We have six of them. They are similar to login nodes, but they do one. They're designed to do one very particular thing. That is moving your data from your server, from your local desktop to Gadi, or from Gadi to to your local machine. So this does not block, does not increase the traffic over the login nodes. So they are dedicated for that purpose. Both of them are connected to outside network, so you can SSH into. The compute nodes, however, which with a large amount, they are air gapped. So they have no connection to the outside world. The only way to connect them is through the login nodes. So all the nodes, the interconnection between them is through this high speed network InfiniBand, 200 gigabits per second. So that's the computer nodes. In between, I have a /home /apps/scratch /gdata and mass data. They are, when you log in the Gadi, they are the directories you can access. A home is a home directory. Apps is all the applications, your software where they are installed. Scratch and GData are the storage service, which we'll talk about a bit later. Mass data is type data system. So basically, the type data system is an archive. They are particularly for long data with longevity. So if you have a 50 years old, 100 years old climate model, which maybe you store them, you don't use them daily, you put them in the type system, because they are very efficient in terms of energy consumption, and they can be stored over for a long time. Okay. Again, this is important slide, so I'll pause here for a second in case you have any questions. At the same time, I'm going to check a Q&A to see if there are any questions. Again, from an anonymous attendee, so is there effectively no cost difference between running a node on 10 cores for 1 hour instead of running it on one core for 10 hours? So I guess when you say core, so I get what you mean. So I will simply say yes, but I'd like to change that core to nodes, because core, I guess when we talk about core, is one thread, or is one core from in a CPU, right? The minimum amount of computer resource you request from Gadi is one node, whatever that node is, and that is usually give you 48 cores already. Just that additional information. Otherwise, yes. Okay. Any further questions regarding these slides? Um, if not, there's one more. If we are compiling a solver for our software, should we source the modules and compile it in our home directory? Okay, cool. I think Abdullah answered that one. Uh, by the way, in the background is our training team manager Abdullah. He will help answer questions in the background as well. Thank you, Abdullah. That saves quite a bit of time. Um, yeah, this is a bit of a wrap up of what I said about the storage server. They are external servers, the GData, and the mass data, the type system. So they are external. They are separated from Gadi. So when Gadi upgrades the data on those machines, they will persist. And when we get a new machine, those data can be easily integrated into the new machine. So therefore, it's persistent. Now it's 10:40. We'll move to be more, I guess, boring but necessary part of account management. We'll take one break, 5 minutes break, 1 hour in. So we'll carry on for another 20 minutes and we'll take 5 minutes break. Um, so Gadi account is a lifetime. So what does that mean is if you change your work, go to a different university, go to industry or whatever, you still retain the same account, which is a combination of alphabet and some digital numbers. So it's not the user account is not your email address because you change job, you change your email address. Always keep the contact information up to date. We recertify every year, so every year we'll send an email to you. You need to change your password and accepting condition of use agreement. It takes you 3 minutes. Um, I know like many other like short emails only take 3 minutes and we just never do it. Um, if you delay this thing, the account will go into suspend for 120 days, and beyond that, it will be deactivated. Once it's deactivated, you need to get back. When you need to get back, you need to write to us the email, and we will send you SMS message. Um, that's why keep contact information up to date is important because if we get to that point, we need the way to actually contact you and to authenticate you. So recertify every year um, when you see the email. Um, so how to log in mynci .org.au. So I will go to a browser. Is my browser here? Uh, yeah, I'll put it in my browser here. So to find us, you can Google find us. This is our website. And the main portal for the account management, in the website, you'll see two things, two websites. One is user guide, another one is your account management. If you click my NCI, um, uh, uh, put in my password. Um, I have it. Actually, I have it here. Um, so it's your username and your password. You log in, and it will come into one portal. Um, and you manage things, your account project through this portal. Okay, this is how you get to the website, do your account admins. Kind of boring stuff. Um, so well, but um, it's fairly straightforward. Now, log in, be more interesting things is how you log in Gadi then to a shell. So actually get to the supercomputer. Um, Let me put on my terminal here. Can everyone see my terminal? Cool. So the way to do is SSH is a secure shell. Usually secure shell takes two ways. One is the credential password. It's your Gadi password. Um, Another way is SSH key, which is the asymmetric cryptography key. Um, the message is confusing. The message I'm gonna give you is confusing, and it's up to your own interpretation. Is password needs to be safe, but to come up with a safe password is not an easy task. Okay, whatever task you think your brain come up with, I'd say it's probably not very safe. So use a password generator. Use a password manager. Um, that requires bit of overhead. Or you can use SSH key. But again, that will requires be overhead. If you're not this is something that you are familiar with, I encourage you. My recommendation is um, find some online tutorial, see how to set up SSH key, make sure you understand it. Otherwise, there will be a problem for some it will become a security problem. Um, for me, I set up SSH key. Well, for me, will be SSH um, minus XY. There are two flags for SSH. Gives you graphic forwarding to the account, your account name, the host for your username at the host name gadi.nci.org.au. Okay. If you set up a SSH key like me, you will just enter a passphrase for SSH key. Otherwise, it's your NCI credential. So once you logged in, uh, you will see a welcome message with a little bit warning. And the next thing is the message of the day. It does not mean we give a message every day, but whatever we put here is something critical. So usually they relate to some hardware, unexpected hardware thing, which is quite rare, or the planned maintenance. So if you have noticed some problems, first thing I guess check message of the day because then problem probably have been reported to us, and we are in the process to rectify, and we'll put a message of the day here. For example, this one here. Um, the first one here, which was be outdated. Next thing here you see is some message about your file storage capacity, uh, how much they're being used, how much they will be um, in the. Do I have something here? Yeah. How many files how many files are in quarantine with respect to different projects? Um, the quarantine is a mechanism we implemented that automates the process for the Scratch storage because Scratch storage is only for files in the Scratch storage space. If they are not touched for 90 days, they'll be put in a quarantine. And once in the quarantine for 2 weeks, and you still have not been retrieved them, they will be deleted permanently. So they'll give you a bit of that information so you can check yourself. So once you logged in, you get um, it tells you which login nodes you are in, and you have a home directory. So this my home directory. You'll get your your home directory. Okay. Essentially, this is what this slide is showing you. SSH username Gadi.nc.org.au as host name. Again, I mentioned at the beginning, if you're using Mac or Linux as your local machine, put up a terminal, you're good to go. Windows, I believe the latest Windows 11 has SSH built-in. Um, Otherwise, you have to use one of the SSH client, party, or mobile extern. Okay. So once you logged in, you will notice that you will be in different login nodes. We have a one, what 10 of them, numbered 1 to 10. Um, because of the load balance, you are not guaranteed to uh, land in the same login nodes once you exit, once you kill the session. So for example, um, if I um, read into the session, oh, this time I'm still in the same nodes, number 4. I'll see. Yeah, this time is different. This is in node number 6. Okay. Um, I talk about message of the day, account status information. This is the information about how many files are in quarantine, how much capacity has been used in your storage directory. Because now you are in the Linux space, you need to get yourself familiar with some Linux commands to be able to work on work in the shell, such as pwd, this directory, cd, this simple commands. Um, you need to also be familiar with at least one editor, Vim, Emacs, well, your choice. Um, If you want, you can also change your Linux shell to your favorite one. I'm not doing this for Gadi, but I'm a Fish user, so I'm not a Bash user. Well, I'm a Fish user. I recommend you try Fish. It's quite more feature rich. For those of you not familiar with shell, this is this is I'll open another one. So this is a language you talk to your machine. Then there are interpreted language that you can interpreted language that talk to machine. The default I think is default is Bash for Linux. Um, you can change this one here is a fish here. So you can change updates your favorite ones through config Gadi login to config. The only thing is make sure you have another session open. So in case you got locked out, because you set up incorrectly, you can still change it. Okay. Um, so login notes, some final comments about login notes. This is for logging on, mainly for logging. So you can edit file, build a program, install software, do this um, basic things in your home directory space in login nodes. You can download, upload small amount of data. The reason why it's small amount is if you do CP or sorry SCP or whatever program that transfer your file from local to Gadi or Gadi to local, that is running program on Gadi, right? And we have this cap that is set for 30 minutes CPU cumulative time limit for your program running on login nodes. So if your data transfer program runs over 30 minutes, the data transfer program will be terminated, or it's run exceeds 4 gigabytes memory. So if you need to transfer large data, you will need to use the data mover nodes, as I mentioned in this slide. Um, the how to use data mover nodes is the host name is changed to of a. You still have your same. Um, actually, you still have your same username. Sorry. That's why you need to use fish, because I actually didn't remember the host name for the data mover nodes, but I have it in my bash history. You SSH with your same username, and the host name has changed to gadi-dm.nci.org.au rather than just gadi.nci.org.au. But it's the same key now. Right. Um, okay, so this is okay. I see what's going on here. So I can ping the login nodes, oh sorry, the data mover nodes, but I don't think the data mover nodes provides you a shell. Um, so when you, but you can use data mover nodes to transfer data. So when you have a, when you use a program such as a CP to transfer your data, I'm on my local machine now. For example, I want to transfer the one of the slides or whatever to um to um Gadi. I can do this with the data mover nodes. So this is so for those of you not familiar with, this is the program doing the remote copy my local file, which is a I need to go to desktop and CI. Okay. P my local file to username at the host name now change to data mover nodes and to my via data mover nodes to my home directory. No such file. There we go. So if I move this slides, okay, this tells me this files transfer is transferred to Gadi. Now if I go to Gadi, this LST, that gives me the bottom one is the latest. The bottom one is the latest um the file, which was the file I transferred from my local to Gadi. So the um upshot of this slide is if your program or whatever you run on login nodes requires more than 30 minutes or exceeds this limit, you need to use data mover nodes. And I showed you how to use data mover nodes by changing the host name. Not just data transferring, some code, if the compilation time requires too long, like some code takes probably more than half an hour to compile, you also need to compile that either through a data mover nodes, because that's compilation is also a program that exceeds the CPU time. Okay. So one last thing about login nodes, what I can do is to submit and monitor the PBS jobs. This is your job submission script. Once your job is submitted, you will return a job ID, which we'll see later, and then you can monitor the job through PBA, monitor a job on the login nodes. So that is more about login nodes. in the slides. We should take a 5 minutes break. But same time, if you have any questions, please leave in the Q&A session. I'll have a look. I see. So any more Q&A sessions, or they have been answered? Okay. Let's take a 5 minutes break now. I'll have a timer set up. All right. We'll be back after the timer. Hello. We're probably gonna get started again. I just noticed there's one problem in Q&A. I'm not sure if I answered that question. I'll just say repeat the question again. If we are compiling a software for our software, should we source the modules and compile it in our own home directory? Um, so the modules, which we'll talk about later, is a mechanism that enables the applications or software installed centrally without without clashing in dependency requirements. So what does that mean is uh, if sorry, it's part of my part notice the sorry, just noticed some problems with my laptop. Um, so what does that mean is if you first thing you go to look out things in modules, and then you source them. If that is there, you don't need to compile them. Then you can just load them and use the software. If you need to compile them, that means I guess you need to get a source code from somewhere else and then compile the code. Hope that makes sense. If not, we'll get to that in this hour. Okay. Let's carry on. Again, I hope everything can see my screen. Next part this of this session is talking about storage. We mentioned about storage a few times already. Here we dive into a bit more details to give you the understanding about um, how different storages service different purposes on this machine, so you can better utilize different storages. Home directory is when you log in the machine, you have the home directory. This is personal space, so it's locked down to anyone but you. It has 10 gigabyte storage space, fixed amount. There's um, no more, no less. If you we won't be able to offer you more than that. It's just by policy. The reason because it's a different file system. It's a network file system. With that, you also get a backup as well. So all your files in home directory, they have a backup. So if you accidentally delete your files in home directory, you will be able to retrieve that. I'll show you how to retrieve this. Um, Let me go to this login nodes. I'm in Peter. The current directory. The place to retrieve your past files in home directory is dot snapshot. So this directory is not visible. Even it's a dot directory, it's not visible when you do ls-i, because ls-i lists all the files with the dot files as well, but this one is invisible. And inside this file, so inside this directory, you will be able to see your daily backups, hourly backups based on the time and day, and then you can go to those folders, say a year ago. I'm going to save. Still file handle, so there's nothing changed. That was not cd. So I'll have to go to another directory, say hourly one, maybe this one a week ago. So here, if I go to this one, this shows my files at that given time. then you can CP copy the files in this was at the time the file still existed and to your to the home directory. I hope that makes sense. So again, the directory is dot snapshot. So is dot snapshot is the directory. Um, um, so I'll highlight here. It's this one. Of course, your home directory, not my home directory, but this is but dot snapshot is the directory for retrieving your the retrieving the time the snapshots. Okay, so that's about home directory. Scratch is the temporary storage space. It's mounted at Scratch and it's mounted to you by the project that you have access to. So this provides fast I/O. It's temporary storage for input and output data. So if your HPC application generates a lot of data, you don't put those data in the home directory because home directory only has 10 gigabytes. It's very easy to exceed that. You put the data in the Scratch space, and you analyze the data, use the data. If you don't need it, you can delete them. The point is, even you lost the data, you can always rerun your HPC application to regenerate the data. So there's no need to have a backup for those data. So file not accessed for 100 days will be automatically removed. There's a backup, as I mentioned. Data once deleted will not be recovered. So you don't put a source code and things like this. Don't put it like important things in Scratch because they will be gone. They're designed to be temporary. On the contrast, the global data, the G data, they are persistent. So they're persistent for long-term data storage. They can also store data from your that are generated from your application. Although my recommendation is still put in the Scratch because G data is persistent. There's no point to put things. I guess you can regenerate in persistent space. Again, there's no backup for G data. G data is not by default given to users. You need to request them particularly for access to G data because that becomes very hard to manage. Because we guarantee once you put in G data, as long as NCI exists, your data will be there. Mass data is the tape data system. Applications is where your software allocates. So let's do some little, I guess, Linux, Unix to get familiarized with those a few comments if this is your first time. So Scratch data is go to CD. It's mounted at Scratch, so /Scratch. So underneath this is they are categorized by all the projects you have access to. So if I have access to VP91, this project, everyone that has access to VP91, aka the members under the same project, they have access to this directory. Just for your awareness, this is no longer just locked down for you. This is shared between the project members. So if I go to GData, similarly, I can go to GData. Those one you will not see VP90 or VP91 also has GData. Your project might not have likely not have a GData space there because again they are available only by request. The applications they are available through apps, but you don't call you don't call invoke or you don't use or call your applications through apps, because we will later talk about modules. Once the module is loaded, they will be in your path. So in the path, which means you can just type the name of the command, name of the software. They should then it will launch. Okay. So some summarized information here. Home directories for data ownership is for users only. Now fixed default 10 gigabytes. Scratch is project wide, 1 TB default. More space can be allocated if reasonable justification is provided. So the question we had before, again, please just write to us to justify the need. GData is project wide. They are accessible only by request. Similarly as mass data, which is the tape data system, they are accessible by a request as well. Okay. So we have a few, in here we provide a few customized utilities for you to monitor the usage of your storage computer resource under a project. So the first thing we can do is quota. So this quota comment with dash minus s gives your usage in your home directory. So in totally the limitation is 10 gigabytes. I've used about 8 gigabytes. Be aware of your usage of your storage in your home directory. A lot of errors would happen if you exceeded your home directory. Errors such as you will be no longer use or your Python will no longer, I guess, when you use Python, you can't install new packages anymore because the packages are installed under the home directory. Things like this. So let's say always give probably 1 gigabyte, something like that, buffer in your home directory. Excuse me. L quota. This gives you this information about your Scratch and GData. So it prints out all the by projects, each project, how much does it have Scratch? In the Scratch, how much is being used? How much is a quota? Sorry. And there has another metric here is I usage and I quota and I limits. They are the metrics concern the inodes. So when we talk about a storage file system, I guess most of the time we care about how much volume we used or how much got left. But there's another very important metric is the number of files you have under that directory. That is the inodes. They're also limited, especially if your program generates a large number of small files. You are likely to also exceed the inodes, the number of files, before you exceed the volumes. So this is another important metric you should watch. If you start seeing errors, you can write more, but you see you still have the volumes, but maybe that's because you exhausted the number of inodes. So for example, this project I have over inodes limitation, and this one as well. Okay. The next one is NCR count. Um, this one gives you a overview about your count of project usage. Say, for example, I use. So for example, I have um hmm, variables, right? Um, and I give you the project VP91 is the one project I mean. Um, by the way, every member in this project will be able to use this will be able to query the information for that project. Let's say it tells me how much usage I've been how much computation resource have been granted, how much have been used, how much is available, um, and it gives more information about also give the information about the footprints in the storage system as well. The other two NCF files report and NCF file expiry, they gives you the files that has been put in the quarantine. Uh, sorry, NCF file report gives you detailed footprints, and NCF file expiry gives you the number of files in quarantine that you can check if you need them back or you don't care about them anymore. Um, Data transfer, how do you transfer data from local to host? This example here use SCP is I demonstrated this um, half an hour ago. Um, the examples are here. So when you do data transfer depends on, I guess, if you use Windows or also depends on the nature of your number of files. There are different protocols, well, utilities you can use. The simple one is SCP. It's just copy over SSH. Another very good one is SFTP, gives you somewhat more um, interactive um, session where you can it tells you, well, yeah, interactive in a way that it tells you there's different commands you can use. There's also async and other ones as well. Async is particularly a popular one do if you care about if you have like large files to transfer and you care about the data integrity. This one have async gives you benefits such as if your transfer interrupted in the middle for whatever reason, and when you resume it, it does not resume from beginning. It pick up from where it stopped, and also it does check some things, make sure the data is make sure your data is integral. In Windows, you can use FileZilla or WinSCP, the different protocols. Um, so that's about data transfer. Next thing, main things we're going to talk about the applications is how you run jobs. How you use how you use software and run jobs on Gadi. I'm going to take a pause here to have a look at the Q&A. If I understand it right, to transfer large data was software requiring long compilation time. You would suggest using a data mover in Node instead of the GUI like CyberDoc. I'm not familiar with CyberDoc, so I don't know how to. I have to look up this to make it to fully comprehend your question. Sorry about that. Second question, how to submit our jobs to Express? Normally with default queue submit gets only to normal thread. You specify queue sub. You specify this with different queue types. So say your normal queue is normal. Your the express is just normal express. This PBS has a flag. You just specify, give that parameter to that flag. Is file client limited by 30 minutes? Yes. So you on the login node, yes. So you need to use data mover nodes to do to a file transfer for over 30 minutes. And sorry about the CyberDoc question. I just have to look it up and get back to you later. Oh, FileZilla. Well, when you use FileZilla, it's the same thing as it's it. So the 30 minutes time limit is running program on the machine, right? No matter what file program you use, if it's over 30 minutes, then it will be terminated on the login node. So you run FileZilla, but you run FileZilla over login nodes as a host name rather than the login. Sorry, you run FileZilla on data mover nodes as your host name rather than login nodes. So question, another question is explain difference between no trouble. Between GData and mass data. GData is again hard disks. So hardware-wise, is hard disk is much faster. So I'm talking about the difference first. I'll talk something in common. The difference is for our GData is basically the same hardware as your Scratch. They are hard disks, so they are faster, and they both run the last parallel file system. Mass data is totally different. It's a tape data system. So on upstairs in the data center, what you see is basically a hallway or the racks of tapes, and you have a robot arms go retrieve the tapes and put them to read into the machine. So there are different hardware where the things in common is that both are persistent. So the data stored there, they will live as long as NCI is around. For users, I guess mass data is slow. It's quite slow. It has much larger. You can store much larger data on tape, but because it requires physically a robot arm get your type, read the type into the machine. We're talking about probably at least couple hours, probably 1 hour, 2 hours to read the large data, from the tape to the machine. But GData is immediate, is instant, right? Okay, the applications, another thing I guess very important. So when you come to use Gadi, you're going to run some softwares. The first thing to do is check if your software is already installed on the machine. And how to check is through modules. So module is do I have a so module is a mechanism implemented this module environment. So basically, it avoids the clashes between different conflicts between different dependencies in different softwares. So, for example, in Python, some use Python 3.8, some people use Python 3.9, and Python, I think, is always the nightmare about its versions. And this problem is addressed with modules because, say, my default Python here, which Python is a system Python, is 3.6.8. If you need to use a different version Python, you can module load Python 3. Let's actually have a look at what Pythons are available because there are multiple versions available on the machine. So you have all these different versions of Pythons available on the machine. Then you can module load. Any one of them, I'll go the latest one or latest one in the machine. And now you do Python, you use Python 3, and it becomes, then you use the latest Python. So softwares will have a centrally installed 200 plus softwares, and they are all available through module avail. It's going to be a long list. So from Abacus, I think that's a CFD, ANSYS, different version of ANSYS, CFD software, to Intel debuggers, profilers, OpenMP libraries, CUDA libraries. So it's a long list of softwares that were centrally installed on this machine, and to use them, you only need to use them as you only need to do is what I just did before: module load the particular software you need to use, and then you can just use that software directly. Because once you do the module, so for example, I'll show a module. Once you do a say ANSYS, what it does is to put it in the path. It put ANSYS it set the relevant environment variables and put in the path, and you can use it directly. For ANSYS, this would be special because this is a licensed software. You do need to make sure you actually have a license, and which we'll talk about a bit later. But overall, this is how you use the softwares that load fully installed. So module, another command is a module list. This list lists all the modules that you have loaded. One is, say, Python 3. This one is loaded. You need to unload this. If you now need to use different version of Python, you can module unload this Python 3.12.1, and then you module load a different version. Otherwise, they will tell you there's conflict. Oh, that was not because I misspelled Python. Now which Python? Well, now if I type which Python, it should give me the original system Python. And then I can load other versions of Python if I need. So this helps us to manage the Python. Well, particularly if you use Python quite a lot, that manages this trouble with different Python versions. Quickly, because I just see this question here. If I can ask for expansion for the annual limit for specific project, yes, you can. Just same as you require extra volume for the Scratch as well. You can just sure, who should I talk to? There towards the end, there's a help tickets. There's a help email. You should write to this email. I'll put it. You can see the email here. Oh, this is the email. You can write help@nci.org.au. This is the email address. Okay, now let's get back. We talk about the software modules. This helps load the dependencies, handles conflicts, and it configures the environment to define how the application runs. For licensed software, if you're running MATLAB or Ancestors licensed one, you need to go to the online portal. So remember, I showed you this online portal, my You need to go to the project, say find the project and group, and type ANSYS. For different projects or different software, the license arrangement is different. For ANSYS, for example, is by universities, your home university, institute. So you need to join your home universities. And we have assigned people, well, then we'll check a list if you actually are eligible to use the license. So once the first thing is you join this project under this license group. Then when you run the job, the PBS, there's a flag, then you need to supply, you specify information about license information to that flag to run the job. So yeah, the steps are here. I will share the slides afterwards as well. Any questions so far with the running software? Central install the software through modules. I'll take a pause here for half minutes and look at the Q&A. Yeah, the recording will be shared. Actually, the recording will be uploaded to, I think we have a YouTube account, and it will be uploaded to YouTube. How can I search a module to see whether it has been installed in Gadi? By search, you mean you want to check if the software is installed, or installed one is in this list. So you just go through lists. But I guess a more clever way you can do is module avail, say Python. What I did was a sort of a fast search with the asterisk symbol here. It listed everything start with the PYTHON. So you can just search if that software in your mind is there by this way. Well, if you can type what software is of your interest, I can have a look right now. What is the usual experience with installing new software on NCI? Our group will often use less common bioinformatics tools. That's a good question. Because we actually encourage, well, although we try to provide Minicon I'll talk about that in a second. I will so for bioinformatics, for software that we are not essentially installed, we always encourage user to install yourself first, because although you can write to us to justify, okay, this is software that we are interested in and we believe it will benefit the wider community as well, and we'll look into it and we will see if it's compatible with the machine, and we'll install it centrally for the users. But this takes a long time because we only do updates quarterly. So at least you can wait for some time. So always try to install yourself. And now when it comes to install software yourself, my personal UI experience is it's just like install as locally. You get the source code, right? Then you build the code, compile code and build the code. It might be tricky when it comes to using different dependencies, right? You need to address that. But mostly dependencies, the common dependencies, well, first you check if the common the dependencies is installed. Then you can load the dependency first. for example, if I many parallel code needs to use open needs to use MPI, and we have a different MPI libraries, open MPI. Sorry, module build. We have different OpenMPI versions, and you load the OpenMPI first as the dependency, then you compile it against this. So in terms of dependency, you need to address your dependency yourself first, and then you follow the build instruction. The thing you have to be very mindful is you can't do so. If you look at the online instruction, then sometimes they're going to tell you, "Oh, do a sudo install blah blah blah." Sudo is a super user privilege, so this is not available to users. Okay, I don't have to use sudo either. It's only the sysadmins have the sudo access. So if you look at some online instructions tells you to sudo install, this is not the way to go to do on Gadi, because this requires you have a sudo privilege. Usually for those ones, they will provide you the documentation will provide you, okay, this is how you do sudo. If you want to install yourself, here's the source code. So you need to go to source code and build the code from the source. I Overall, I personally never really had big problems installing softwares on Gadi. There's sometimes needs to be tweak and needs to be tweak and stuff like that, but usually it's fairly smooth. And again, I should also emphasize, if you have a problem, install your source code yourself, write us an email, and we have a dedicated team to help you with that. That's another thing I can't stress enough is if you have problems with the machine, particularly compiling code, install code, we are here to help you. Okay, so that's my personal account. Move to the second question. The Miniconda. So Miniconda, I believe I don't use Miniconda personally. I use UV. If you're familiar with that, or Python virtual environment, you can, for all the Python things, what you can do is, for example, if I want to use a Python virtual environment, I load a particular version of Python, 3. And what I can do is with this Python, with this particular Python version, I can create a virtual environment. Just demo the This will just be come to the bottom of this, a folder. What I can do is I can cd to this virtual environment. I'll put it on top. Now you can see I have a virtual environment activated. So I'm now in the virtual environment associated with this particular version of Python. What does it mean is I can do all the Python packaging install in separately within this virtual environment. So if I do Python, say 3, Um, excuse me. And I plan to use, say, NumPy, which will tell me there's no NumPy here because I installed a very clean minimum virtual environment, just like Miniconda. And all I need to do here is Python 3 pip install NumPy. And then the NumPy package is installed within this virtual environment, just like Miniconda. Um, Now I do Python 3 and import NumPy, and I have NumPy here. And if I don't need to use this virtual environment anymore, I can just do deactivate. See, this thing is gone now. This prefix is gone now. And if I don't like this virtual environment, I can just remove this virtual environment, just as simple remove directory. So this is a I guess what we recommend to use virtual environment over Conda. Miniconda is not bad. I just not on top of my head how to install Miniconda. I can have a quick look here if this. Okay, install through Pipe. Um, Maybe you can install through Pipe. Um, I'll get back to that. So if you need to use packaging, and last question, if you need to use packaging R, do I need to separately load them as well? Yes, because we also provide different version of R. This you need to load whatever version you like to use um, through module as well. For the interest of time, I'm going to move on this part about applications. I understand there's a lot of questions about how to use a particular software that you are interested. The takeaway message here is firstly check if they are in the centrally installed modules. If they are, use them. If not, try to build them. Go to find the source code, build them yourselves. And if you have problems when you build this software, you can always email us, and we'll be able to give you help. Um, with the Conda, I just want to say one thing is clusters, shared systems don't like users to use Conda because Conda is basically half operating system. It gives you a whole bunch of its things that you conflicts with the native hardware. For example, it gives you your own low level libraries, which you never use. This is how Conda achieves sort of independent, like the portability. You basically have a half operating system and takes a lot of space in the home directory as well. This comes at the cost of the performance because you are no longer within Conda, you no longer use the system's optimized libraries. You use Conda's libraries, which is generic. So this one reason is supercomputer facilities don't advise users not to use Conda. Miniconda is not that bad, but I'd say Python virtual environment or UV is a better option. Okay, last 10 minutes, I'm just going to go through the jobs. For interest time, I will not do demos. I will just walk you through the slides. So PBS jobs is you need to write a job script to submit the jobs to the machine. There has certain actually I will probably use I can use I think I will use some um example here. It's now transfer file here. So what you'll see is I have a script here. Just got span bin bash tells it's bash script. Um, PBS, we have a customized PBS. So if you go Google online, the PBS, some flags, most flags does not transfer to this machine because we have a customized PBS um, job scheduler. So to help us user to use PBS easier. So we have different queues. So it start with project. So the project PBS start with the hashtag PBS minus P project. P91 is the project where you where this job is drawing resources from. Next one is Q. The orders does not really matter, but I like this order. It's just be more hierarchical. PBS hashtag PBS minus Q tells different Q. This is copy Q. This will use um, this is this this queue is running data mover nodes that will that running on data mover nodes that usually people use this for copy jobs or copy files data. Number of CPUs, number of members requested, war time. This is the maximum time this job will run. So once the job hits this war time, the job will is terminated automatically by the job scheduler. This is different from the time that your job will get charged. By that, I mean, say if you request 4 hours, but your job is actually only run for 2 seconds, you will be charged by the for that 2 seconds, not the 4 hours you requested. However, when you start the job, it checks if you have enough resources to run the maximum 4 hours you requested. If you don't have enough resources or quota left to run the wartime that you requested, your job will not start running. Storage, it's if you need to access data in different storage spaces, you need to specify them here. The default is Scratch BP91, but say if in this one I need to transfer data to GData from under another project, I need to specify that with a plus sign here. You can output the error to this error log to a specified error log, output log to the specified output log. This is all working directory. And below this, so those are the PBS parameters you need to set for the job scheduler to schedule a job. And below this is your job related, set up environment variables and your executables. And then you will submit this job. So how we submit the job is through job schedulers. Job scheduler come up with a few commands. Q sub is Q submission, followed by your job submission script. Once it's submitted, it will return a job ID, and you can query this with another command qstat. This tells this job is in the queue now. Which queue this is in. If you have more details, it's there's another. You can give a flag SNW that gives you more details. All right, so this is about these slides. So few commands you need to know is, I guess most importantly, is qsub, like submit a job, and check a job status is qstat. If you delete a job, in this qdel followed by your job ID. Okay. I can. Yeah. Lastly, I want to talk about the compute resources. So in order to run a job, Your project needs to have a adequate computer allocations, a, aka service units reserved for this job. So one SU gets you 30 minutes of one CPU time in a normal queue. The question we had before, how do you change normal queue to express? You change this thing from queue normal to normal express. There are more options when it comes to different queue types, depends on your job load. Go to the user guide, and there's a queue structure here. Have different queue. These are different queues. Express, change this to express. Your job will be run on express queue, and the express queue means you run this node. If you have a large memory job, you have a huge mem as queue name as well. Or if you want to use older GPUs, CPUs, as I mentioned, you need to change them to normal BW board wheel, so on and so forth. So have a look at the user guide and see which queue is most suitable for you. Okay. So the PBS job scheduler will calculate the total number of SU depending on the wall time. So SU, the charge rate SU times number of CPUs times wall time, and to calculate the number, see if you have enough reservation under your project. If yes, and it will run. If not, it will not run. One thing is for users, the quota is evenly distributed. So you apply every the quota is given for a year, but it's distributed over 4 quarters. So if you get 100 KSU quota, then by default, each quarter you will get 25 KSU. And we understand, research, you don't use, say, one semester you need to teach, one semester you do more research. You don't use the resource evenly. So have a look at your agenda, look ahead of the year. Tell us, you can email us, okay, in next 3 months, I don't really use I don't see myself use the resource. Can you roll my resource from this quarter to next quarter? Usually we're able to accommodate that. But if you write us at the end of the quarter, when you have a whole bunch of unused resources and tell us, okay, can I do this? We probably won't be able to accommodate that. So the earlier you give us the heads up, write to us, the earlier we can accommodate that need. So you don't waste your quota. Hope that makes sense. Here's just different. This table shows your different charging rates for different type of queues. Express queue, of course, this is fast, means you pay a bit more, I guess. The charge with your higher rate, you can always calculate yourself beforehand. Compute resources, again, this is the command I showed you previously, which you can track your usage of quota under a specific project. Because we're getting towards the end, I will skip this example here, which basically the same thing but running a different program here. So underneath below these parameters you gave to the PBS job scheduler, you run the job, you run your executables, you run your running command. If your job requires some dependencies, you also need to module load them in this job scheduler. Actually, that is quite important because you run your job in computer nodes. The module loads, the software you loaded in your login nodes does not transfer automatically to the computer nodes. So you need to load them again in the compute nodes, and you do this by specifying this by specifying this in your JavaScript. I hope that makes sense. We're pretty much get to the end, so I'll skip this job monitoring part. And there's few reasons. Sometimes you don't see your job is running. So we always do qstats to check what's the information there is. Usually the reason insufficient amount of resources. Another reason is your project is really over this quota, so that's what I mean. Always keep give some buffer in your home directory, and the same as your Scratch as well. Waiting for software license. Job will not finish before dedicated time. Dedicated time, this means if you have maintenance scheduled on this day, if your job will not finish by the wartime, will not finish before that dedicated day, it will not run. So, just because the maintenance day, we need to shut the machine. Eventually, okay, so all in all, I talk about a whole bunch of things about the machine. And I understand some parts I probably talked too quickly about. But you have any problems, we have a team here. I guess there's a difference between have a research dedicated supercomputer rather than commercial commercial data centers. So we're actually here to help users. If you have if you need help, write to the help desk. Your user service team is we have a user service team, and part of their job mission is monitoring the help desk and help users with the need. When you write to us with job-related queries, include your job ID, avoid attachment, but screenshots are okay. In this way, we will be able to actually go to the path and see what's going on, check the logs and see what's going on with the job. If you need additional allocation, if you know who's your institute's scheme manager, who is responsible for allocating resources to the people in that institute or university, then you can contact that person. I guess first the chain of command is if you talk to your supervisor first. If your supervisor knows, then good. If not, your supervisor can write to us, then I'll figure out from there. I think that concludes the session. I think I went a couple minutes over. Again, thank you for everyone's attention. And hopefully you find this thing is somewhat helpful. I will have a look at the Q&A now for this few. I'll see this few remaining ones and try to help out. Try to give some answer to the Q&A. But that's the main session concluded. Thank you, everyone. Have a good day. All right. So in the Q&A, there's a few ones here. Yeah, so the question, do I get a copy of slides? The slides were emailed to you. So I mark this answered. One more question. In NCI user guide, I saw there's a description about one GPU will be charged as 12 CPUs, and I didn't fully understand this. So for example, do I need this number GPU 1 and number CPU 12 together? Yes, that's the case. The reason being, one GPU node also have CPU as well. So this GPU node always come with the CPU. So for example, the node I believe will be 4 on the GPU node. It has 4 GPU cards with 48 CPU cores. So when you request one CPU, I think all the hardware on hardware level, the architecture is one GPU is attached to probably 12 CPUs. Sorry, 12 cores. So one GPU card attached to 12 CPUs in a NUMA node. So it's when you request one GPU, it's equivalent to request 12 CPUs. Because you are essentially using the same resource as by the configuration of the architecture. So you always need to specify both number of GPUs and number of CPUs, and they should be important as well. So if you require two GPUs, you need to specify some number of CPUs as 24, so on and so forth. So does that answer your question? You're welcome. And this question, will I be in charge of the memory assigned with memory access gigabytes, or how much is I think there's a will I be charged for the memory assigned with yes, memory assigned. I kind of skim over this one. So the charging is by max of NCPU or memory units. For example, you can request one CPU, one core, but you use all available memories. In that case, you are charged with um, using the same node because at that time you are using the entire node. Even you just use one core, but you are using the whole memory of that node. So so whichever is greater, you are charging with that number of CPU or memory units. I hope that answers the question. And this question from Chris Marshall. When running on super rapid nodes, 104 cores, yes, I've noticed the CPU time used summarized at the end of is often much higher than all time. Yeah, that is true. That one's the multiplication of CPUs. It's not the actual time. It's the multiplication of either number of CPUs or number of NUMA nodes. But that is yeah, you're right. So hopefully that answers that question. If I need many cores and I need more than one node, how can I request in the script? Um, sorry, that's a good question. Sorry, I didn't get that in the first place. If you need one more course, I'll put up my dummy example here. What you request is say change this to say normal. Um, standard PBS. Well, if you come up with Slurm, it has the Slurm is another. Sorry, I should be clear. Slurm is another job scheduler. It will. If you have experience with those, you probably see they have a flag or number of nodes. We have a customized PBS. We simplify this. It's just number of CPUs. So if you normal queue gives a cascade like, which has 48 cores. So if you just put a 96 cores, the PBS scheduler automatically knows you need two nodes. So that makes it easier for the users because you don't have to worry about number of nodes, how many number of nodes I need to request it. You just need to give the number of cores, and then the PBS job will find the number of corresponding nodes for you. But again, you need to update the memory to the multiple sorry to the memory on each node multiplied by the number of nodes. So one node, the memory on the one normal queue node is 190. You request two, you need to update to 380. And hope that makes sense. Thank you. I think that's all the questions I have in my Q&A. It's one more. What costs the storage equals story min. Can I direct to other storage paths like media flux? Um, so this is the storage here only so only at the mount point for your on the machine. So you can direct this to other projects that's available to you. If you add the storage path, I'm by other storage paths you mean other directories? Or other mounting points? I never tried personally. I never tried the other mounting points besides Scratch and GData. Um, so I need to actually take notes on this. Do you mind actually leave an email here so I can write back to you? Because I'm not sure. I need to double check and write and get back to you if you're okay with it. Or you can write to my email as well. I will type my email here. I'll type my email and you can write to me. And then I'll follow up with you. I'm not sure it's configured because I'm just not sure if our customized PBS is configured to see other mounting points. Cool. All right. Yeah. If there's no other questions, I'll conclude this. Again, thank you very much, everyone, for your attention, and I hope you have a good night.